All right, our lesson objective is I can identify basic features of sine and cosine functions. So here we have the two major functions we're going to learn about graphing today. We have our sine function and our cosine function. So the main part that we're going to really focus on today is the amplitude of the graph, which is half the height of the graph. Really, how far away does this graph go from the x-axis? Because the thing is, this side, this height, and this height, they're all equivalent. And these are known as the amplitude. And if you notice, the graph also repeats. It actually repeats in as a and that's why we call these periodic functions. So if you notice, this function repeats, and you could literally take this one part here and shift it over here, and you'll get the same function back. So then if we look at cosine, we also have an amplitude here, an amplitude here, an amplitude here. But then our period is going to look a bit different. So the period will be from here to here. Now, the major difference between a sine function and a cosine function is that the sine function starts at the x-axis, the cosine function does not. And if we were to generalize this further, we refer to both of these functions as sinusoidal functions. And we're going to actually write this with the definition on the next page. And we also will, specifically in the real world, use the phrase periodic functions when describing real world events. So again, the vocabulary, we have sinusoidal functions, which are, so it's just another way of saying a generalized sine function. So we have periodic functions, which are functions that repeat at regular intervals. So the period of a function is the length of a cycle, and it can start at any point on a graph. And then the amplitude is half the distance between the minimum and maximum values. So if you recall, we used special right triangles with a hypotenuse of 1 to create the unit circle. So this has a hypotenuse here of 1. And it says which leg on the triangle represented cosine, which leg represented sine. So I like to always say that we really think about this as x and y values. And we think of x as cosine of theta, and we think of y as sine of theta. So let's look at the graph for y equals sine of x. I have a misspelled word here that's supposed to just say yarn. Okay, I'm not doing that on this because it's the Whiteboard app, but you can use the you can use that to help yourself graph this. But we're just going to actually go ahead and so again, if you can use the yarn to measure the length of the side associated with the sine ratio on the unit circle, break the yarn to match this length, and glue this onto the graph at the corresponding angle perpendicular to the x-axis. And hint, if the sine value is negative, where should you glue the piece of yarn? Okay, so remember that our values for sine are going to be within the unit circle. So sine of x will always be between 0 and 1. So we're going in increments here. If you notice, pi over 6, pi over 4, pi over 3. That is the values of our unit circle. So what I'm going to do is actually start with writing 1 and -1. And then we're going to use our values of the unit circle. So we're going to use the values 1/2, and then we're also going to use the values square root of 2 over 2, comma, square root of 3 over 2. And then we're also going to use the values -1/2, negative square root of 2 over 2, negative square root of 3 over 2. And then we go ahead and we start to graph our values. So we have sine of pi over 6. That's going to be 1/2. Then we have sine of pi over 4. That's going to be square root of 2 over 2. Then we have sine of the square root of 3. That's going to be radical 3. Then we have sine of pi over 2, and that's just 1. And then we're going to really just follow this same pattern now. It's actually not so bad because once you start the pattern, you actually end up just staying with this pattern the whole time. And the difference is that when you go down below the x-axis, you just go to the corresponding value. So I'm going to go ahead and now draw. This is one period right here. So then I'm going to go ahead and I'm going to draw the rest of the graph. And then we just want to make sure we have arrows at the end. And then also we have here the amplitude. And what we also have in this graph is this other line. And of course, it just seems like the x-axis, but this is really the midline. And if you think about it, it's the line that goes through the middle of the graph. So use a pencil to make a smooth curve that connects the ends of the yarn. Definitely want to make that look much better than the one I did. So it says, what do you notice about this shape of the graph? So the shape of the graph, it is a wave. And that's because when you move around the unit circle, the y value increases from 0 to 1, then decreases to -1, then increases again. So that's everything I just said. And it says, what is the highest and lowest point in the graph? So the highest point is 1. The lowest point is also 1. So it says, how long does it take until the graph starts repeating? So it repeats every 2 pi radians, and that's 360 degrees. And now it says we use special right triangles with a hypotenuse of length 1 to create the unit circle. Which leg on the right triangle represent the sine? Which leg? I don't know why I have this again on here. Oh my goodness, that's not helping me at all. Okay, anyway, so yeah, it takes 2 pi radians, or 360 degrees, and that's why the period for a sine function is 2 pi. In other words, every 2 pi radians, the graph repeats. Now we're going to do the same thing with cosine of x. So we're just going to go through and actually follow the exact same procedure. So we are first going to have our value 1, -1, and then we're going to have, I'm going to give myself a little more room to make it a little more smoother. So we have 1/2, and then it's square root of 2 over 2, square root of 3 over 2. Then in the below the x-axis, we have -1/2, negative square root of 2 over 2, negative square root of 3 over 2. Now I'm going to go ahead and draw my graph. So cosine of 0 is 1. If you remember, cosine of 0 degrees, you're going to be on the x-axis. If you're on the you're 1 to the right on the x-axis. Now cosine of pi over 6, this again, 3, 2, 1 rule. So we go 3, 2, 1. And that's how we get cosine of pi over 6 is radical 3 over 2. Cosine of pi over 4 is radical 2 over 2. And then we just continue the same process. So we, at pi over 2, that is where cosine is going to be 0. Then we have negative pi over 2, -1/2, negative radical 3 over 2, -1. Then we're going to have the same values. Okay, what is the highest point 1? What's the lowest point -1? How long does it take for the graph to start repeating? 2 pi radian, which is 360 degrees. Okay, it says, how are they similar? So they are both waves between 1 and -1. And they both repeat every 2 pi radians. And what's different, cosine starts at the max and sine starts at the origin. So we're going to reinforce some of this stuff. Given f of x equals a sine of bx or f of x equals a cosine of bx, the amplitude is going to be the absolute value of a, and the period is going to be 2 pi divided by the absolute value of b. So let's get started. So the amplitude for number 1 is going to be just 1 because we have 1 in front of x. And then the period's going to be 2 pi over 4, which is going to be pi over 2. Now for number 2, we have the amplitude is going to be 7/2. The period's going to be 2 pi. And then for number 3, we have a equals -5. And then the period is going to be 2 pi over 1/3, which is going to be 2 pi times 3, which is 6 pi. Then for number 4, we're going to have the amplitude is 2. Remember, we say the amplitude has to be positive. And then for the period, we're going to have 2 pi divided by 4/3, which is 2 pi times 3/4, which is going to be 3 pi over 2. After this lesson, you can identify the amplitude and period of basic sine and cosine graphs.